So in this lesson, we're going to be taking a look at the chain rule. So by the end of this lesson, you should be able to use the chain rule to be able to find the derivative of composite functions. So what is, well, when we're talking about composite functions, what we talked about in the last lesson was not so much doing the composition of two functions, but doing the opposite. Taking a complex function and thinking of it as two functions that had been combined together using composition. So we want to be able to think of a complex function as being composed of two simpler ones. As composition of two simpler functions. And I'll throw the word "the" in there to make it grammatically correct. So if we have something like h at x equals x squared plus 2 squared, we can think of this as being made up of two simpler functions. F at x equals x squared, g at x equals x squared plus 2, and we can think of h at x as being the composition of f at x and g at x. We're basically taking g at x, subbing it inside f at x where we see x, and combining our two functions. So h at x would be f at g at x. What does this have to do with the chain rule? Well, let's look at what the chain rule actually is. The chain rule says that if you have a function, like h at x here, which you have made by the composition of two simpler functions, so if h at x is equal to f at g at x, and let's say both f and g are differentiable, fix that, differentiable. And when I say differentiable, it just means that you can actually take the derivatives of these functions. Okay? So if we've got this function that we're thinking of as a composition of two simpler functions, the chain rule tells us that the derivative h primed at x is given by f primed, so the derivative of that outer function that we've subbed g into, f primed evaluated with g at x, the original function g at x subbed into it. So we're doing the composition of the derivative of f with g at x, and then we multiply the whole thing by the derivative of that function that we've subbed inside, so g primed at x. Now, sometimes you will see this written with an extra variable thrown in. Okay? We'll say that our function f at x is, actually I should be consistent here. I'll say h at x. So our original function h at x is some function with some variable other than x. Let's call it u. And u itself is a function of x. So I'm basically just taking this other function that I had subbed in there and replacing it by this new variable u. The derivative here, h primed at x, would be, well, the derivative of this outer function f, so f primed, still evaluated at this inner function, u, but then multiplied by the derivative of that inner function, so u primed. And that's our chain rule. So let's quickly apply that to the function that we created up above. We had this function, give ourselves a bit more room here, f at x equals x squared plus 2, and then that whole thing was squared. And then we wanted to find, if we want to find the derivative of this, we said, okay, let's break it down into two functions that have been composed together. We had sort of our outer function here, which was the something to the x squared, and we had the inner function, which was the x squared plus 2. So let's set u equal to x squared plus 2. That's our inner function. And our outer function, I guess we'll have to call it g this time. So we'll say that this is actually g at u. So g at u is something squared. So we'll call it u squared. Okay. So our function f at x is some function, two functions composed together. Our inner function is u, which is x squared plus 2. Our outer function is whatever that inner thing is, all squared. Okay. Chain rule says that to find the derivative of f, we need the derivatives of both of these functions. So we can find u primed, and we can find g primed at u. Well, u primed is going to be just 2x. G primed is going to be 2u. Okay. So let's put this together in the chain rule here. Our derivative, f primed at x, is going to be g primed at u times u primed. Let's see. G primed at u is 2u. U primed is 2x. And if I want to express this in terms of x, I can just take what I've got here for u and sub it in where u is. So this will be 2 times x squared plus 2 all times 2x. And then if I wanted to, I could expand and simplify, but usually this is more useful to me in factored form. So I'm just going to leave it as 4x times x squared plus 2. And that would be my derivative.